Hello, hello. This is the My Artifact episode number 3921. Today's date is 4th of March 2026. It's been almost like a night at 10:39 p.m. All right, let's just jump into the question. All right. Okay, the question is, why does water cause object become wet when it touches? Oh, that's a really good question. I love this kind of like a silly question. Okay, first of all, what is at least this question and why am I asking this question to myself? Okay, so basically this thing, there are so many questions are actually exist in our surrounding, a kind of like a tiny questions, and I always like wanted to know that why things are there, like why the leaf are green, why the trees are look green not red, why the sky looks blue not yellow, why the sun looks yellow not blue. Okay, why am I brown, why am I, like basically this is not asking kind of like a very stupid question to kind of like a thing like I always think like that, and I just never really like I always ignore that question, like it's just like a stupid question and things like that and that. But it's just like that na ki a couple of week ago, okay, I was kind of like a somebody is this thing that ki no, I just have to ask this question in Artifact. I just need to understand this kind of like a somebody simple question. So I need a catalog of this all those questions and things like that. I went to ChatGPT, kind of like a say that ki I have this question. I wanted to ask a kind of like a simple stupid question to understand the things around me and that and that. So ChatGPT kind of like give me almost like hundreds of questions, and this is one of the first question. Okay, yeah. So why water kind of like a feels wet? Okay, feels wet or why like yeah. Okay, so this is like a really good kind of like a somebody question. Okay, first of all, let me tell you what is actually the property of water. Okay, so everything that you are seeing are in three different state. Okay, first state is a gas, another is a liquid, and another is a solid. Okay, solid is like things that you feel. This is the AC outdoor unit that I have. Okay, this is a kind of like a wall. Okay, like everything that has a kind of like a somebody the strong, that is a solid. Okay, liquid, well, we shouldn't like I shouldn't supposed to be kind of like a tell you what is actually liquid. We all know there are liquid everywhere, things that you kind of like somebody see, that he feels and things and that it like that is liquid. Water, oil, petroleum. Okay, like whatever you see kind of like a liquid, that is a liquid. Gases is a kind of like some gases that you feel and things and that and that. Okay, now let me, these are kind of like a three state. There are also another state too. Plasma is also another state, but we will not going to talk about that. Plasma is a kind of like a very different state. It's just like it's a very different. Okay, yeah, that is also state is also available, but those are for the very deep scientific stuff for the people who we don't talk about that. These are the three main state. Okay, now why does those three states are kind of like a bit more different? Is because of the kind of like assembly how much molecules are kind of like holding each other. Okay, what is actually molecules? Okay, okay, let's just take an example. Okay, so I have kind of like assembly cup of water. Okay, no, just like a kind of like assembly is this thing. I have kind of like an ice cube. Okay, I put that ice cube in tawa. Now what is actually tawa? Okay, you don't know the tawa. Pan. Okay, pan might be really good. Okay, so I put that kind of like a something ice cube in tawa. Okay, I didn't turn on the gas. I didn't turn on the kind of like a fire. No, I just kind of like a put it as it is. Then that kind of like a solid converted into the kind of like a liquid automatically. How this actually happened? We didn't start the fire. How it actually happened? Is because of the room temperature. Okay, in room temperature probably we have almost like a maybe 25 degree, 30 degree. Probably I'm living in India, almost like a 28 degree are kind of like a nominal room temperature. Now because of nominal room temperature are almost like a 25 or 30 things and that, That means the room temperature is almost like a 25, 30, that in that. And the ice cube temperature is kind of like a far less colder. It is ice is because of that the temperature of that ice is a kind of like a less than 0 degree Celsius. But the problem is that the kind of like some heat is actually transfer. Now how the heat is actually transfer? Thermodynamics law. Okay, like heat, like is it thermodynamics? I'm not really sure about that, but it's kind of like assembly is this thing that the ice is kind of like assembly transfer heat from itself to surrounding. If you're not really understanding this thing, open the fridge. Do you feel colder even if you don't really touch it? You feel colder. That is called kind of like assembly is this thing that energy is kind of like a transfer on the surrounding. Like if something is actually fire, you kind of like a feel like warm. You are kind of like a feet away from the fire, but still you feel little bit of warm. That is because of that energy transfer. Okay, in its surrounding and things and that. Same thing happened with the ice cube. Okay, yeah. So ice cube is a kind of like assembly is this thing. It kind of like assembly transfer the heat, and that's why it kind of like a melt. It converted into the liquid. Okay, if you do the same experiment in a space, it will not gonna happen anything at all. The ice cube will always be an ice cube. If you do this same experiment in the space, because in the space there is no medium at all, there is nothing really at all, so it just kind of like a stays there. It might gonna change according to the kind of like a heat and things and that, or if you kind of like simply add a room temperature, something happened, I don't know, but probably is this thing in the space things might not gonna happen. Probably. Okay, I'm kind of like a give you the disclaimer regarding about that. Like it's kind of like it's a very scientific kind stuff that I have to kind of like provide you kind of like a disclaimer. Okay, the information that I'm trying to tell you is not exactly right or is not exactly wrong either. It's a raw, it's unfiltered, it's just my opinion. So do not believe in any kind of like information that I'm saying, or do not seek for any kind of like information that I'm saying. It's just my opinion, and opinion are subjective. Now regarding about this kind of like a question, the question is kind of like a bit more something like that like a scientific point of perspective, and like I already kind of like give you disclaimer, so you kind of like simply aware of that. Okay, I'm just kind of like telling my whatever the information that I have throughout the entire life I collected information, I'm trying to tell you. Okay, so my experiment is that ice cube converted into the liquid in that pan. Okay, now how this actually happened, I already mentioned it kind of like simply transfer heat to the surrounding and things and that. Okay, now because of this thing actually happened. Okay, but why, like why this actually happened, like why this actually happened? Okay, so what we can like why it kind of like simply happened, that is a really good question. Okay, why it actually happened? Okay, okay. So in the nature, there is a kind of like assembly law to kind of like assembly to kind of like assembly this thing that is stable in itself. Okay, means like that. It's a, how do I supposed to explain? It's a kind of like a very very kind of like a very difficult. It's not really difficult. Also, I'm kind of like a very not really good at science kind of like stuff, but I'm trying to tell you. Okay, I don't know how do I supposed to explain, but let me tell you something like that. Okay, I live in India. I'm not really sure where are you from. Probably you are kind of like a simply different part of, you are kind of like a living in different part of the world. Okay, I live in India. The average temperature are here is almost like a 25 to 30 degree. Okay, so the average temperature are here. Sometime it kind of like a more than that. Okay, right now temperature is almost like a 29 degrees Celsius. Okay, so this is a kind of like a 29 degrees Celsius. That means let's just say today's temperature is 29 degrees Celsius. So that means everything is inside in India, not inside, like a basically like basically is not completely entirely, like I would not gonna talk about the kind of like a demographic point of perspective, because the temperature and science does not really act according to the demographic. It act according to the kind of like assembly place and things like that. Okay, so I'm gonna kind of like assembly tell you is this thing, the where am I living, like basically is this thing, this is my hometown, and my average temperature today is 29 degrees Celsius. So that means everything is in 29 degrees Celsius. Okay, yeah, not everything 29 degrees Celsius, like basically every kind of like assembly stuff, every stuff, like basically this wall, this kind of like assembly, the pipe and water and kind of like everything are kind of like a try to close to the kind of like a room temperature, try to close to the kind of like assembly room temperature, to try to close to the kind of like assembly is like basically what exactly is the thing na? It's a it's a kind of like a thing that key like I don't know, I'm trying to simplify it in a simple way, but probably it's a very hard to kind of like describe in simple way. It's a kind of like a thing that na ki, like every object's temperature, every object has a kind of like a different temperature. Okay, yeah, and every object has a kind of like a try to maintain that temperature. Okay, maintain that temperature. Okay, yeah. Means like that, let me tell you one thing. Okay, yeah, if you do this experiment in maybe kind of like a Greenland, or maybe kind of like somebody that key Sweden, or maybe somewhere where kind of like a temperature a bit more colder, then ice cube will not gonna melt. Why? Is because of in their room temperature probably is like 0 degrees Celsius or 1 degree Celsius. So their room temperature is kind of like already kind of like a freezing. So why that kind of like assembly the ice cube will gonna melt? It will not. Okay, because like in India, if I try to do this experiment in India, the ice cube wanted to meet that room temperature. How much room temperature? 29 degrees Celsius. So that's why it kind of like a melt. But if you do this same experiment in kind of like a Sweden, then probably it will not gonna melt. Because of that, the room temperature in Sweden probably almost like a 4 degrees Celsius. So probably it might not gonna melt that much, or maybe it might take very long to melt. Okay, so this is what it is. So every objects are kind of like try to meet its temperature to the room temperature. Okay, room temperature or kind of like things like that. Okay, so that's why it kind of like melt. The process of heat, like process of energy also transfer during the process, during this process too. Okay, yeah. I don't know, sometimes I just feel like that a scientific kind of like a don't believe me, whatever the okay, because every kind of like stuff that I'm saying is I don't really have like a proper definition according to it, but I just kind of like somebody like I kind of like somebody get that thing is like basically it's in science. If you wanted to learn science is not meant to be kind of like a learn if you have like a you just need a kind of like a scientific degree and things and that. I see stuff in my surrounding and I'm trying to tell you. So that's why I don't really have proper definition. I don't really have proper kind of like a things like things like I don't know how to supposed to explain a definition or kind of like a nomenclature. I don't really have. I just kind of like seen it. I'm trying to tell you. Okay, yeah. Now, okay. So first time I mentioned a kind of like a state, solid to liquid, liquid to gas. Okay, yeah. Every material are kind of like a goes from that step. Okay, yeah. If the solid, first it converted into the liquid and then it converted into the gas when the temperature rises. When the temperature kind of like assembly cool down, then that gases converted into the kind of like a liquid and then converted into the solid. Okay, yeah. There is no like every kind of like assembly, every material or every molecule kind of like do this same process from solid to liquid to gas, or if it colder then gases to liquid to solid. Okay, yeah, this is what it is. There is no kind of like assembly jump actually happened. Some material or some elements do jump, like it will kind of like a solid to become gas, but those are kind of like a very special material, like we will not going to talk about that. That's a very different thing. Okay, yeah. So let me do you understand now? Each state has a kind of like a molecules. Okay, let me tell you one thing regarding about molecules. Okay, yeah. So basically is this thing, the everything that you are seeing in this world are made up by atom. Okay, yeah. Like basically you, me, everyone are kind of like a made up by atom. Okay, yeah. Now what is actually atom? Atom is a kind of like a very tiny blocks, like basically a Lego blocks. Okay, yeah, like a kind of like imagine as a kind of like a Lego. You kind of like a stitch one block to another, one block to another, create a kind of like entire piece. This is what kind of like assembly atom. Okay, yeah, it's a very tiny thing. Okay, now basically what does it does is that key that atom is a kind of like assembly is this thing that key connected with each other, as I mentioned, connected with each other and create a kind of like a something a molecule or things like that, or maybe kind of like elements, and that element kind of like a multiples of element create a molecules. I'm not gonna try to deep on this thing because I don't really knew that much either. Okay, yeah, but it's kind of like imagine as a kind of like a multiples of elements are kind of like a stacked together, or kind of like a multiples of Lego blocks are kind of like a stacked together. So basically, imagine that Lego block is a molecules. Okay, Lego block is a molecules. Now each Lego block has a kind of like a multiples of slot beneath and top. Like they have kind of like a circle and kind of like assembly. Yeah, so you can fix that thing. Okay, so that is called they are kind of like assembly stack. Okay, so imagine that thing, a kind of like a I am the molecule, I have a hand, and there is another molecule, that means another person who has also a hand, and we are holding a hand. So we are holding a hand, that means we are connected, we are actually connected. This is what kind of like a molecules are actually kind of like a connected with each other. Okay, now let me tell you one thing. When we are solid means like that ki, like a basically let's just say ice cube is kind of like a very much solid. That means me as a molecule A and my side is a molecule B is a far less close to me, very close to me, like legitly very close to me. Okay, yeah, so that's why like every molecule there are kind of like a millions of trillions of molecules in every kind of like a material and things like that. Those are kind of like a very close to each other. That's why it became solid. Okay, yeah, now when it converted into the liquid, that space, the distance between one molecule to another molecule became like a larger, became like a became like it creates a gap. Okay, so there is a kind of like another molecule which is kind of like a little bit far away if I'm kind of like simply liquid. Now if I am a gas, then that distance is even more better, even more longer. Okay, even more longer. So that's why it became gas. Okay, do you get it? All right. Now regarding about our question, the question is that why does kind of like assembly water kind of like a feel wet? Okay, yeah. So water is a kind of like a thing that na ki is a kind of like a property of liquid, and liquid as a property of kind of like assembly is this thing, kind of like the molecules are always want something, like they always kind of like assembly is this thing that ki they just wants to hold your hand. Okay, if you're still not really understanding this thing, okay, just imagine the kind of like a 10 people. Okay, yeah, 10 people are kind of like a holding hand together. Okay, imagine those 10 people are 10 molecules. Okay, yeah. Now what exactly happened that key the if those 10 people are so close to each other, they became solid. As I mentioned, the distance became larger, became liquid. Distance became even more larger, became gas. Okay, yeah. So what exactly happened? What exactly happened? Okay. So basically is this thing, let's just say that key when the kind of like a people, when those 10 people are kind of like so close to each other, then there is no gap to go something in between them. Why? Because they are kind of like so close to each other, right? So they will not gonna kind of like somebody touch it. Wait. Okay, yeah. I got the OTP. I don't know why it get the OTP. Dude, my internet is whatever. Okay, yeah. So okay, so what was I trying to tell you? So basically is this thing that when you are kind of like so close to each other, like all those 10 people are kind of like so close to each other. So if there is a kind of like so close to each other, if I try to penetrate them, can I able to do that thing? I cannot, or maybe I can. It really required a lot of effort. Imagine as a kind of like a 10 people who are kind of like standing so close to them, they are holding hand and they are kind of like a shoulder to shoulder, they are kind of like a touching each other, like a legitly kind of like a creating a human wall. Now would you try to penetrate them? Can you do that? Well, you can, but you really require a lot of effort to do that, right? And as also is this thing, it's not. So that's why this is kind of like a solid, it feels like that. Okay, let me tell you one thing. Like this is the kind of like a simply wall. Okay, let me tell you. Okay, this is not wall, this is a mobile phone. Okay, you kind of like a hearing this mobile phone. Okay, yeah, you kind of like a understanding the sound. Okay, listen to the sound. Okay, so this is a mobile phone that I have, is a solid. Okay, yeah. Now am I touching the my mobile phone, or am I kind of like a tapping my mobile phone like this? Okay, does my hand penetrate the mobile phone? No, it does not. Why? Because the molecule are kind of like a so close to each other. So that's why a solid is a kind of like a solid, feel really solid, that you cannot penetrate. You cannot penetrate. So that's why it became solid. Okay, yeah. Now basically is this thing. If the liquid, then can I penetrate? Yeah, we can penetrate. Like you could put your finger into the water. Yeah, you could put your finger into the water. And why this actually happened is because of the molecule are far away from each other. Far away from each other. Alright, yeah. Now let me tell you one thing, what is actually happened. Okay. So when the kind of like a molecule are far away from each other, they are kind of like a some thing, they wanted to kind of like a contact. But because of they are kind of like a far away from each other, they are not able to contact. Okay, yeah. When something is kind of like a try to contact them, they hold their hands. Okay, yeah. Like basically this thing, what is actually imagine is this thing, that 10 people who are kind of like a standing, but kind of like a little bit far away. Okay, kind of like a 1 feet distance in between 10 people. Okay, yeah. So if I try to penetrate them, can I penetrate? Yeah, penetrate. Yeah, I can penetrate. But when I try to penetrate, they also touch me too. They also kind of like a things like that. They also wanted to touch me and things and that. They also kind of like a hold my hands and things and that and that. Okay, yeah, this is what exactly thing happened. Because of that, when you are in the liquid state, you can penetrate your finger into the liquid, is because of that the kind of like molecules are try to contact with you too, because the distance between them is kind of like a far more away, and they are wanted to contact with you. Okay, yeah, but they can't. Okay, why? Why they can't is because of that they really require a kind of like a reaction to do this thing. Let me tell you one thing. If one molecule wants to connect another molecule, they can't. Why? They really require a kind of like a reaction to do this thing. Okay, yeah. Now what is actually reaction? Okay, let me give you kind of take a water, put the salt in it. Okay, yeah, stir it, drink water. That water kind of like feels salty, right? Why? Is because of that, okay, you put the salt and you kind of like stir it. Okay, yeah. So salt is a NaCl, okay, like a sodium chloride. Okay, this is a chemical formula. Okay, yeah. And it kind of like a soluble. Okay, like basically it can kind of like a basically dissolve like a the kind of like somebody is this thing that key salt is kind of like a dissolve in the water, and that's why it kind of like a chemical reaction happen. Not chemical reaction, but kind of like a somebody is this thing that key it just became like a salty. The water became salty. Okay, yeah, like it became soluble, right? Now what you should do, the next example, you put the glass of water and you put a kind of like a something a solid particle or something like that. Let's just say you put the nut. Okay, yeah, a mechanical nut you put there and try to stir that thing. Now that kind of like a nut, mechanical nut, will be soluble in the water? Well, it will not. Why? Because it's a solid, right? Yeah. But dude, the salt particle are also solid too. So why they kind of like a dissolve so easily and mechanical nut is not dissolved that much easily? Why? Is because of that they are in very small size as compared to the mechanical nut. Those are kind of like a very big size. So should I kind of like somebody that key like a cramp it a little bit? Like if I kind of like put a kind of like a pieces of mechanical nut, will they soluble? No, they will not gonna be soluble. Why? Because a mechanical nut particles are still in small quantities or maybe small in size, but still they are kind of like elements are not. Okay, means like that if I kind of like a put the particles of the kind of like a iron material, because those are mechanical nuts are made of iron. Okay, if I put this thing, is a iron is not made to kind of like a do this thing. If iron wants to connect another molecules, they really require higher amount of heat, then they will try to connect with the another molecule. With the room temperature, you can't do this thing, but with the with the salt, it can happen so easily, because salt are kind of like a very much kind of like a easily things, like a basically is this thing now. Every material really required a kind of like a reaction to connect with each other or connect with another each other and things like that. Now that reaction is a kind of like a bit more different from every material. Okay, like iron really required to do chemical reaction with another elements when there is a heat up. So that's why when the kind of like iron converted into the liquid, then you kind of like put any kind of like it kind of like do the chemical composition and things and that and that. Okay, yeah, but iron does not kind of like do the chemical reaction in the room temperature because the heat is not that much. But sodium chloride are do this thing because they doesn't really require that much amount of kind of like some chemical reaction and things and that and that. Okay, so they just kind of like did it. Okay. Sound okay. Right now I'm kind of like a feeling that ki, oh, I'm kind of like saying a lot of science stuff. Kind of like I'm trying feel like that I'm kind of like teaching myself scientific stuff. Okay, so the question is that ki, why does kind of like a water feel wet? Okay, so let me tell you one thing is this thing that ki, not water but any kind of like a liquid, it doesn't really feel anything at all. Okay, like the question is actually about that ki, why does, like let's just say, okay, if I put the mechanical nut into the water, does mechanical nut get wet? It might get little bit of flashes of kind of like a couple of water droplets, but it might not get wet, right? Now if I put the paper in it, does it get wet? Yeah, it does get wet. Why? Because as I mentioned, the iron particle, like mechanical nut is actually made of iron particle, are very difficult to do chemical reaction. It really required a kind of like a higher heat to do chemical reaction. Okay, so that's why it does not do chemical reaction. That's why it does not do kind of like a soluble. It does not do any kind of like a chemical reaction. But the paper, it does, because paper are kind of like a is this thing, like there is no kind of like a is this thing that ki a reaction happened, but it's a kind of like a things that na ki the paper particles are also kind of like a far away from each other. They have also molecules which are also inviting them to connect. Okay, like kind of like a feel that na. Okay, let's just say this is the kind of like a 10 people who are kind of like a holding their hand and very tightly. Those are kind of like a iron particle. Okay, like a iron particle. And there is a kind of like a paper particle. Paper particle are kind of like a wanted to like a kind of like a hold each other hands, and they also kind of like a hold other people hand too. Okay, like basically this thing, imagine as a kind of like somebody that the 10 people who are kind of like a holding hand, they are kind of like a very introvert. Like they just kind of like a made a clan, and they just kind of like somebody don't do kind of like a chemical reaction until and unless heat is actually happened. If that heat is not gonna happen, they will not gonna connect with each other. So there is a kind of like a introvert. Okay, but the paper particle are kind of like an extrovert kind of like a people who are just whoever the person would kind of like a see, they just kind of like a hug it, kind of like a be friendly and things and that and that. Okay, so that's why the paper particle are kind of like a somebody hugging the kind of like a somebody the water particle or water molecules. Okay, and that's why it get wet. That's why it kind of like a get wet. Same thing happened with the wood, but takes time. Okay, a paper kind of like it very easily, but a kind of like somebody the wood, it also happened but little bit delay. Okay, it happened little bit delay. Okay, do you understand? Now the question is that okay, why does water feel wet? Now we didn't really feel wet. Like a wet is a kind of like a somebody way of expression. There is no scientific term for wet. What do you mean by that? Okay, let me tell you one thing. Like basically this thing, when you put the piece of paper into the water, okay, that piece of paper get wet, means literally there is a kind of like a water molecule or get inside the paper molecules. Okay, yeah, because paper molecules are wanted to hug and things like that, and also water molecules are also wanted to get hug and things like that. So they just kind of like a mix and combine and things and that. So that's why it became wet. But if you put the finger in water, it does not happen. Why? Because still is this thing, we are not that strong enough to kind of like iron, but we are kind of like a little bit strong enough to not let another kind of like a molecule inside our body. Why? Because still is this thing that we are also have a kind of like a little bit strong connection, things like that. So basically our water finger does not get wet, but we feel wet now. We feel wet, like we feel kind of like a colder. So why? Is because of that a sensory organ. We are kind of like a sensing a kind of like a things, like a basically this thing that we are sensing the temperature difference. Okay, let's just say if you touch the ice cube, you feel colder in your palm of a hand. Why? Because you are kind of like a somebody is this thing, your palm of hand is kind of like a sensing the temperature, na, a cold and things and that. Same thing happened when you touch the water. The water temperature is kind of like a far less colder than room temperature. So that's why it kind of like a feel colder. Okay, yeah. And also another thing is that when you try to kind of like somebody is this thing, it's a kind of like also create the pressure in between them. Okay, yeah. That's why it kind of like somebody brain resonate that it kind of like became wet. Okay, yeah. So yeah, this is what it is. So basically wet is a kind of like expression of say this thing. Okay, yeah. But it's not. It's a kind of like some this thing we feel kind of like very different. Okay, let's just give the same example. Okay, what you have to do is that you put the finger in the water. Okay, yeah, feel little bit of kind of like some cold temperature and feel little bit of kind of like a pressure or something like that, or not that much pressure, kind of like somebody kind of like a difference in your hand. That's what kind of like a feel wet, but that is not. It just way of expression. It depends on some certain situation. What do you mean? Let's just say rainy season, you are kind of like wearing a kind of like a shoes very soggy, like a very soggy, yeah, like a kind of like some shoes are kind of like a very soggy, and then you kind of like somebody open up the shoes and then you realize that your entire leg are kind of like somebody soaking, like it's kind of like a feel like kind of like somebody just soak a lot of amount of water. This actually happened when your body is more amount of time contact with the water, then it try to accumulate some sort of water inside. So when it actually happened, your hand get kind of like a little bit of something like I don't know how you're supposed to. You actually feel that, na? It's when you put the kind of like a lot of like when you are kind of like a swimming so much amount of time, your hand kind of like a look something different. Different means like that ki like something that ki like some sort of water inside your body and things like that. This is what actually happened. Okay, so this is what basically is this thing, like if you are very dry and you just put the finger, you might not feel that much amount of wet, but you are swimming for almost like an hour, then after that your body kind of like a feel like that, okay, you have kind of like somebody in between, you kind of like a suck little bit of water inside your body from the skin and things and that. Because let me tell you one thing, our skin has a pores too, like a small tiny holes in our skin. Okay, yeah, in everywhere. Why does we have that small hole? Is because of that we are mammals and we get sweat, and that sweat actually came from that pores. Okay, yeah. So yeah, we have that thing. Okay, so that's why when you do swimming, sometimes that water kind of like goes from that. I'm not really sure what exactly happened, but it actually happened. That's why kind of like we feel wet. Okay, yeah. Now you have to do same experiment with the petrol. Okay, yeah. You might have kind of like a petrol. Put the finger in the petrol. Okay, yeah. Do you feel wet? You might gonna feel little bit of wet too. Okay, yeah. Mercury. Okay, yeah. You put the things. Does you feel little bit of wet? You might not feel kind of. It felt kind of like I didn't really touch the kind of like a things, but like it felt very weird. Okay, very weird. It does not feel wet. It feel weird. Okay. You have to do one thing. Honey. Put the finger in honey. Okay, then you realize that, oh, it's a very different. Okay, so let me tell you one thing. Every liquid thing is not kind of like a get you wet. Wet is a kind of like some expression of our brain imagine, because the temperature difference and things and that and that. Weight is not a kind of like a scientific thing. It's just not. Okay, yeah. It's a kind of like our brain thinks like that. Okay, yeah. So this is how water can make wet. I don't know. I'm kind of like a feel really good asking such a question to myself. I don't know. I will gonna ask this question. Like, I don't know. Sometimes I just feel like that asking this scientific question kind of like a feel really good. And also is this thing when I ask this question to myself, I just understand even more regarding about this science stuff. It felt really good. Yeah. All right. So this is thing actually happened. All right. Disclaimer. I already kind of like define you. Still, again, I will kind of like give you disclaimer. The information that I'm trying to tell you, or information that I already tell, is not exactly right. Is not exactly wrong either. Okay, because I am not a kind of like somebody, a kind of like somebody specific person regarding about that. I kind of like see whatever, like I kind of like feel whatever I see and things and that. That's what I'm trying to tell you. My words, or maybe my maybe kind of like some the statement might not be exactly right, but things what I experience and try to tell you this thing. Okay, yeah. So don't consider it as a kind of like a legit information. If you want, go to the internet. You will kind of like get very verified information. Okay, but this is what I kind of like experience throughout my life. All right, this is it. Thank you.